All right, today we're going to talk about long division with polynomials. But before we do that, let's go back to elementary school and remind ourselves how to do division by hand. All right, so maybe in elementary you had this question, 746 divided by 3. So remember what we did in elementary? You put that 746 in the house, maybe you called it a house, and put the 3 on the outside. And then what would you do? Well, you would ask yourself, how many times does 3 go into 7? Well, 2 times. 2 times 3 is 6. Then you subtract, you get 1, and you bring down the next number of 4. Then you ask yourself again, how many times does 3 go into 14? Well, 4 times. 4 times 3 is 12. Subtract 2, bring down the 6. How many times does 3 go into 26? Well, 8. 24. Subtract, and I have 2. Well, I can't do anything more with that, okay? So then I would put my answer, I could put it as a remainder, and I would write it as 2 over 3. Now, let me remind you of some terms, okay? When we did this number right here is called the divisor. This number under the house is called the dividend. And then whatever you end up here is, right, the remainder. So if there is a remainder, that means that 3, in this case, this divisor, was not a factor because there is a remainder. For it to be a factor, it means there has a remainder of 0. Okay, so the same process is what we're going to do. We're just going to throw in some variables today. All right, let's try this out with a polynomial. So this is what goes under the little division house, if you might want to call it that. So I'll have x squared plus 9x plus 20. And this is the divisor, x plus 4. Now, when you divide polynomials, you want to make sure you get rid of that lead term right here. So you focus on that, okay? So what this number x times what gives me x squared? Well, hopefully you know that that's just x. Now what you're doing is multiplying or distributing this x right here across this divisor. So I'll have x squared plus 4x, and I draw my line. Now you got to make sure you remember we subtracted here. Remember this up here? We subtracted. So let's do the subtraction here and see what we get. So that lead term should cancel out. Now 9 minus 4 is 5x, and then bring down the next number, plus 20. Then you ask yourself again, what times this x gives me 5x? Well, that would be a plus 5. Then I distribute that 5, so it's 5x plus 20. Change your signs and subtract. So that goes away, and then this is 0. So now with a remainder of 0, the question is this divisor a factor? So you would say yes. Okay? So maybe make yourself a note. Is it a factor? Then it's yes, means no remainder. Yes, if it's no remainder. It is a factor if there's no remainder when you divide. Now, the other thing I wanted to point out to you is that on every round that you do with this division, you know how you keep repeating the process? Here's a round and here's a round. You need that lead term, whatever's in the front, to be subtracted out. So it must cancel out on every term. So on every round, the lead term must cancel out. That's how you know you're doing it correctly, is if you focus on that first lead term after you've subtracted and get rid of it. All right, let's try another one. This one's going to have a remainder, so let's walk our way through it. So x squared minus 7x plus 13 divided by x minus 5. So here's my lead term. I need to get rid of that. So I ask myself, x times what gives me x squared? So it's just x. Distribute. So I'll have x squared minus 5x. Then I want to make sure and change my signs, right? It becomes negative. This becomes a positive. And I subtract. So this lead term goes away. And now I'll have negative 2x. Bring that 13 down. So then I ask myself, okay, what do I need to multiply x by to get negative 2x? A negative 2. So I would say negative 2 times x gives me negative 2x plus 10, change my signs. That becomes a plus, this becomes a minus, and then I do my subtraction. Lead term is gone, but now I have a remainder of 3, okay? So the way I would write that is since that 3 is a positive 3, I put a plus, and I put 3 over whatever my divisor was. So it's 3 over x plus 5. This is my answer. So then the question is, well, is x minus 5 a factor of this polynomial? Well, since we had a remainder, this is not a factor, so you would just say no, it's not a factor. Let's try another one. This one's a little longer. All right, on number 3, negative 5x cubed plus 2x squared plus 3x to the 4th plus 3x minus 2 divided by 3x minus 2. All right, so it's a much longer polynomial. Now I want you to notice that it is not in exponent order. This is your highest exponent, and really it should go in the front, shouldn't it? So before you put it in the house, you got to make sure the exponents go in descending order. So I want to make sure they're in that order when I put them under there. So 3x to the 4th minus 5x to the 3rd plus 2x squared plus 3x minus 2. All right, now I'm ready to do my division. If you put them out of order, it's not going to work, so just give you a heads up on that. Now we're going to walk through the same exact process we did before. So what do I need to multiply 3x by to get 3x to the 4th? Well, I have the 3. I just need more x's, so I'm going to multiply it by x to the 3rd. So x to the 3rd times 3x is 3x to the 4th minus, distribute, you'll get 2x to the 3rd. Then we go through and we change our signs, right? This becomes a minus, this becomes a plus. That lead term goes away like it's supposed to. All right, if we combine these, we end up with a negative 3x cubed plus 2x squared. And then we repeat the process. We go another round. So we have the 3's, they match, but we need it to be negative. So I'm going to do a negative 1 times 3 gives me negative 3. I need some more x's to make it x to the 3rd. So I need x squared times x gives me x to the 3rd. So now it's going to be negative 3x to the 3rd. Distribute that's going to give me a plus 2x squared. Now, as I change my signs, this lead term cancels out, and this one actually is going to cancel out as well. So then I just bring down my next term. It's 3x. Well, what do I need to multiply 3x by to get 3x? Well, it's just a 1. So if I do that, I distribute that 1, I get 3x minus 2. I need that negative 2 to be under something. So that means I'm just going to bring down that next term. It doesn't always happen like this, but it can. So don't let that trip you up. Sometimes you bring down 2 terms at a time if necessary. Now, I'm going to change my signs. These will cancel, and I have 0 remainder. So then the question is this a factor of the polynomial? Then the answer is just yes. We have no remainder. So since there's no remainder, that means that the 3x minus 2 is a factor of the bigger polynomial. Now, before we get off this page, let's just make ourselves a little note. What was different about this question originally? Remember, we had to make sure the dividend is in exponent order. That matters. It really, really, really matters, okay? So make yourself a note, and then we're going to try another one that has another little quirk to it. All right, on number 4, we have x cubed minus 3x squared plus 1 divided by x minus 1. So I'm going to put x minus 1 on the outside. Now, look at this. It goes x cubed minus x squared, but notice that there is no x term in here. When there's a missing exponent, you have to put in a placeholder. So 0x needs to be there because it's x to the 1st, and then you have plus 1. All right, so you want to make sure that you always put placeholders for missing exponents in your dividend, okay? Always put placeholders in for missing exponent powers, okay? It won't work unless you do that, and I'm going to show you why. Okay, let's walk through this question. You'll see why. All right, so again, x times what gives me x to the 3rd? Well, that would be x squared. So if I distribute that, that will give me x cubed. Negative 1 times x squared is minus x squared. Change my signs. That goes away. And now I'll have negative 2x squared. And I'm going to bring this down, 0x plus 0x. Now what do I need to multiply x by to get negative 2x squared? Well, a negative 2, and I need another x. So I'm going to have negative 2x squared be a plus 2x now. Change my signs. And let's do the subtraction. That goes away. This now is a negative 2x, and I can bring down the plus 1. Now I multiply by a negative 2. That's what I need it to be. Negative 2x plus 2. Change my signs. This becomes a plus. This becomes a minus. So that the lead term goes away, and I'll have a negative 1. Now, to write my remainder, since this 1 is negative, I'm going to put a minus sign here, and then I'm going to put the 1 over the divisor, x minus 1. And this is my answer. Now, is x minus 1 a factor? It's no. Because there's a remainder, it's not a factor. All right? So you can see why we needed that placeholder right here. Now let's try the next one. All right, let's do this last one, number 5. So I'll have x squared plus 1 as the divisor. Underneath, let's look at our exponents. I'm going to start x to the 4th. I don't have an x to the 3rd, so I'm going to put a placeholder in. 0x to the 3rd plus 4x squared. I don't have an x to the 1st power, so I'm going to put 0x and then plus 3. Now let's see what happens as we go each round. All right, so what do I need to multiply x squared by to get to x to the 4th? Well, an x squared. If I distribute that, I'll have x to the 4th plus, let's see, 1 times x squared is x squared. Now I wouldn't put it right here because this is x cubed. So I put it over here, 1x squared. Now change my signs. Now in this case, we didn't really need that placeholder, but sometimes you do, so you always want to put it in. You won't know until you try. So this cancels out. This becomes 3x squared. I'm going to bring down the 0x and see what happens. Well, what do I need to multiply x squared by to get 3x squared? A 3. If I distribute, I'll have 3x squared. 3 times 1 is 3. Well, again, it's not going to go under here, so I need to bring down the next term. It will go under here. Now I'll go back and change my signs and clean it up. So this has a remainder of 0. So x squared plus 3 is my answer, and yes, x squared plus 1 is a factor of the polynomial. So why did we do this? Well, because I just want to show you, sometimes you need the placeholders, sometimes you don't, but there's no way to know from the get-go. So always put them in there so that you can make sure you line up your powers accordingly. Otherwise, it gets really confusing. So take your time, do this. Now, a sidebar, if it is a factor, you can always check your work. If you go back and do FOIL, this times this, you should end up back with the original dividend that we had. All right, so you can always check your work if you'd like. But this is how you do long division with polynomials. I hope it makes sense. Let me know what questions you have when we get to class.